Okay, Assalamualaikum. So now let's proceed to Norton theorem. So just now you have done for simulation for Thevenin theorem. So now Norton theorem. So for Norton theorem, I want to do for the step 1 and step 2 first. For step 1, connect the circuit as figure 2.10. Okay, number 2, measure the current through R3 and voltage. So number 1 and 2, you want to connect the figure as 2.10. Okay, and then to find current and voltage at R3. Okay, so basically the resistor is same as Thevenin theorem before. So let's look at simulation. So here the value of 12 volt, 12 volt to a resistor 1, resistor 2, resistor 3. So now let's measure the current and voltage. So simulate them. So for the current, we have 2.451 milliampere. Okay, for the voltage, for the voltage we have 8.0882 volt. So done for part 1 and part 2. So now let's proceed to step 3 and step 4. So step 3, remove the R3 and then measure the current, where the current is equal to IN. And then number 4, construct the circuit as figure 2.11b and replace the voltage source with a short circuit, and then record it as a RN. So let's do for step 3 and 4. So circuit 2.11 A and 11 B. So now let's go to the simulation. So now remove the R3. Okay. So voltage also remove. So now connect circuit. So now simulate the circuit. So current that is equal to 0.01 ampere. So this is value for IN. Okay, now let's proceed to step 4. Construct the circuit as figure 2.11b and then replace the voltage source with a short circuit and record its RN. So basically this circuit. So now let's do it for simulation. So this is voltage source have been replaced with short circuit. Okay, so the value resistor. So in simulation, there is no device to measure the resistor. So in order to determine the RTH, the circuit must connect in this way to get the RTH. Okay, so here the RTH is equal to V over IR. So here we want to measure the voltage. So here I been inject the voltage approximate to 0, okay, which is 0.00001, okay, volt. So it is equivalent to 0 volt. Okay, so now connect the voltage to find voltage. So let's simulate them. Okay, so voltage we get 8.9286 to the power of minus 5. So this is for voltage. So now let's measure for the current. So current, so this is the current probe. Okay, so simulate. So for the current, we get 8.333 to the power of minus 8. So here you can find RTH by voltage divided by current. So the Rn will be approximately about 1.071 kilo ohm. So done for step 4 and step 3 and step 4. So now let's proceed to step 5 and step 6. So step 5 and step 6, you construct the circuit in figure 2.1. Okay, using the Rn that we get before this, and then measure the current and voltage through R3. Okay, so now let's connect the circuit 2.12. So this one, so connect the circuit this one. Okay, so you have IN, Rn and R. So IN, Rn and R 3.3 kilo ohm. So IN we got just now is 0.01. So place the 0.01 IN, and then Rn is 1.071 kilo ohm, and then remain the R3. So now let's measure the current and the voltage. So let's simulate the circuit. Okay, so the current is 2.4502 milliampere, and then for voltage is 8.08579 volt. Okay, that is for voltage. So now you connect the circuit as shown in figure 2.12. Okay, this circuit. So we have IN, Rn. Okay, IN 0.01 and Rn is equal to 1.071 kilo ohm. So okay, for 7, 8, 9, 10 step 7, 8, 9, 10, okay, you calculate by your own by using the value from the simulation. So that's all for experiment 2. Okay, Assalamualaikum and thank you.